Good morning. My name is Lorena Matos, and it's my last year of chemical engineering at the Polytechnic University of Madrid. Today, I have some questions for you. Have you ever wondered if the air we breathe is clean enough or too polluted for us to live? Have you ever wondered the size of the air particulates? All along this presentation about air pollution, we will give answer to this question, and we will get a wider knowledge about the air we are surrounded by every day. This presentation will focus on four main topics: green chemistry, sulfur dioxide emission, particulates in air pollution, and air quality. Well, first topic to deal with is green chemistry. On the one hand, we have carbon dioxide, a solvent which is receiving considerable attention as a replacement for traditional organic solvents. The decaffeination of coffee and tea with carbon dioxide is a good example of a modern application of this solvent. To dissolve many organic molecules, a substance with low purity and high solubility is required. So, as to increase solubility, surfactants such as soaps and detergents can be used. On the other hand, we have ionic liquids to replace organic solvent. Ionic liquids are non-volatile, and thus their potential to replace bugs is of a significant interest. Ionic liquids may also be purified and recycled. Once we have spoken about green chemistry, let's proceed to talk about sulfur-based emission from three different approaches: emission, production, and reduction. Some sulfur dioxide is emitted into air directly as sulfur dioxide, or indirectly as hydrogen sulfide. As hydrogen sulfide is a highly poisonous substance, it is of utmost importance to remove it from gases before their dispersal in air. Production of sulfur dioxide are volcanoes, gases produced by the decomposition of plants, and the combustion of coal. For reducing sulfur dioxide emission, calcium oxide or calcium carbonate are used to trap the sulfur dioxide from gases. Here we have a graph. In this graph are different emission and different year in this graph. The line is the different zones that all of them decrease since this point, but in China, in East Asia, is the line black began to decrease in 2007 year. Okay, now I am going to continue with particles in air pollution. Particles are tiny solid or liquid particles which are temporarily suspended in air. Breathing air that contains particles can be hazardous to human health. There are many common names for atmospheric particles. Dust and soot refer to solid particles, whereas mist and fog refers to liquid ones. Air particles are separated into groups: fine or coarse particles. Fine particles usually remain in the air for days or weeks, whereas coarse particles set out rapidly. Fine particles are formatory mainly by chemical reaction between gases or inorganic compounds of sulfur of nitrogen. Coarse particles are produced by windstorm in desert, pollens from plants, wildfire and volcanic eruption, and human activities. The last point is air quality indices and side characteristics from particulates matter. Ultimately, the effect of particulates suspended in air upon human health depends significantly upon the size of the particles involved. experts have made a common measure of the concentration of suspended particles is the PM index. The usual units are microgram of particles matter per cubic. The classification are 5 types: PM10, PM2.5, PM between 2.5 and 10, ultrafines and nanoparticles. PM10, all the particles having diameters less than 10 micrometers. These are called inalienable particles. PM2.5 are fine particles, called respirable particles. PM2.5 between 2.5 and 10 are coarse particles. Ultrafines are particles with 0.1 micrometers of diameter, and nanoparticles are particles less than about 0.02 micrometers. Here we have other graph. I show you. In this graph, show the particles air quality in major world cities. Here is the PM10 index, and here is the different cities, important cities in the world. The green horizontal line is the WHO air quality guideline. We can see that New York is the city nearest from this guideline, and the Karachi, other city, is the farthest city from this guideline. I show you. Okay. To conclude, if you have to take an idea from this video, remember that there will always be air pollution, but we have to look for ways to replace or reduce pollutants. Well, thank you so much. Thank you very much for your attention. If you have any question, you can write me an email.